All right. Like I said earlier, before I started recording, this is one of those landmark lessons. This is one of those lessons that when you look at geometry or you look at algebra, even in algebra, this is kind of an algebra topic as well. It's probably maybe more of an algebra topic, I guess. I don't know. But it's all math, right? This is one of those ones that really stand out, that really make a difference in your math, that you use a lot, okay? This is something that you use a whole bunch. So it's important. It's a very, very important lesson. So let's keep that in mind. It's named after a guy, I think I might have talked about this before, but it's called Pythagorean. Pythagorean, yeah, I spelled it right. It's named after a guy a long time ago, and I forgot to change my pen settings. Let's change that to that. Okay, now we're good. It's named after a guy named Pythagoras. Pythagoras. Way back in the day, it seemed like people only had one name, right? There was, think of all your Bible characters. Did anybody have a last name? It was like Peter and John and Abraham and Isaac, right? Everybody had a first name. I was listening to a sports radio channel today, and they were talking about this guy in the beginning of the show. Every day he gives some trivia, and he said that it wasn't up till, when was the time? I don't know. There was a certain time when, I think even up through the 1700s maybe, that people normally just had a first and last name. They never had a middle name. I think he was talking about John Adams, because there's also John Quincy Adams, right, which was, I believe, his son. All right, but normally we didn't have middle names. Now everybody's got a middle name. All right, now people have two last names. All right, I mean, so we have a whole bunch of names, probably because there's a lot more people, right? And so that's why we have more names. But this guy just had one name. His name was Pythagoras. He goes back way before even Jesus, even before Christ. He was born in 570 BC, and he died in 495 BC. That's before Christ. So 500, almost 600 years before Jesus, this guy was walking around, Pythagoras. He was a mathematician, but he was also a philosopher. He was a teacher. You know how Jesus had 12 disciples? It wasn't really that weird back then for people to, for a leader, a teacher, to have people following him around. So Jesus having 12 disciples wasn't odd. Today it would be kind of weird, wouldn't it? One person walking around and, you got a dozen people just following him everywhere they go. That would be kind of weird, all right? Back then it wasn't, because they didn't have institutional schools and things like that, right? They didn't have a seminary where you could go and learn the Bible. They didn't have, buildings for schools that kids would all go to in the morning and stuff. Maybe you would like that better. I don't know, all right, since you're complaining about school today. But Pythagoras, he actually had students that would follow him around, very similar to what Jesus was, okay? He never claimed to be a god or anything like that, or God, but that's the way they taught back then. They'd have somebody that was really smart. People would say, oh, I want to learn from that guy. And they'd follow him around, and the guy would just walk around, teach them a whole bunch of stuff. That's who Pythagoras was. You would think they called this the Pythagorean Theorem because why? Why would you think they gave the name to Pythagoras? Because he came up with it, exactly. Wouldn't you think? Usually that's why they give people these names, okay? But it's not. They actually knew about the Pythagorean Theorem. They didn't call it that, but they knew about this theorem way before Pythagoras was even around. But the thing that Pythagoras did, he came up with a nice proof that people could understand, I should say, a nice proof that people could understand of that particular theorem, right? And then after a while, I don't know when it first caught on. I don't even know if it caught on when he was alive. But eventually, at some point, I haven't done that much research on it, but at some point, they started calling it the Pythagorean Theorem. So let's show you what the Pythagorean Theorem is. In my notes, you see my notes right there? I've got a whole bunch of stuff. That's all right there, the proof of the Pythagorean Theorem. I'm not going to go through that because I literally have 3 minutes left. So let's just talk, and we're just going to introduce the Pythagorean Theorem to you. So the Pythagorean Theorem is only used with right triangles. That's super important that you understand that. So I'm going to draw a right triangle right here. You only use Pythagorean Theorem with right triangles. Okay? We got to know the names of these sides of the triangle. So this side right here is called a leg. This side right here is called a leg. What's this side? This side's the important Well, they're all important, but this was pretty important. It's got its own special name. Anybody know what this side is right here? Starts with an H. Hypotenuse. Very good. You've heard that before, haven't you? I've probably talked about the hypotenuse in here before. Right? How do you know it's the hypotenuse? Well, it's because it's opposite the right angle. You see how it's opposite the right angle? And another thing about the hypotenuse is that it's always going to be the longest side of the right triangle. So the hypotenuse is always the longest side of the right triangle. Does that mean the longest side of any triangle is the hypotenuse? No, because you could have an acute triangle and have a longest side. That's not the hypotenuse. You can have an obtuse triangle and you could have a longest side, but that's not the hypotenuse. What's the hypotenuse? The hypotenuse is opposite the what? The right angle. You can only have a hypotenuse on a right triangle. Everybody with me? Now, what they usually do, they usually call one of the legs, they'll call it A. Doesn't matter which one they call it. Doesn't matter. All right? And they call the other leg, what do you think they call the other leg? B. All right? So either one of the legs is A and B. It doesn't matter. It's the shortest leg, the longest leg. It doesn't matter. Okay, just one leg is A and one leg is B. Everybody with me? So what do you think they're going to call the hypotenuse? They're going to call it C. That does matter. Okay, the C absolutely matters. The C is always the hypotenuse in this situation. All right? Everybody with me so far? So they came up a long time ago. I don't know. They probably don't even know who came up with this. I don't know. People just knew about it. And because they knew a lot of math. I mean, look, Pythagoras was over 500 years before Jesus, right? And it seems like Jesus was a long time ago. He was 2,000 years ago. So this is over 2,500 years ago. I can't even imagine. I can't even think that far, you know? But they knew how to do this long before Pythagoras. So here it is. I'm going to give it to you. It's a squared. I tell people all the time. Well, not all the time. It's when I teach this. I tell people when I teach this, Pythagorean theorem is as easy as, what do you think? A, B, C. That's right. So here it is. It's A squared plus, and you probably know it. What is the rest of it? Do you know it? B squared equals C squared. Very good. Okay? Everybody with me on that? That's easy. Well, at least memorizing it's easy. It's as easy as what? ABC. All right? So, how do we use it? Well, I'm glad you asked. Let's do just a couple little things here. What if I said that that leg was 3 and that leg was 4? Figure out what the hypotenuse is. We don't have much time, so how do you know it's 5? Just because 3, 4, and 5 goes in order? What if this was 2 and this was 3? Would this be 4? Well, let's see if this is actually 5. You said 5. I don't know if I believe you. All right? It is 5, by the way. But let's just see if it works. So what do? Put it into this. This is 3 squared plus what? 4 squared. And that equals what? C squared. Well, let's do the math. 3 squared is 9 plus 4 squared is 16. And that's going to equal C squared. 9 plus 16 is 25. Look, we just did a problem in our homework, didn't we? Where we had the squared thing. So it actually works out kind of nice. Maybe that's why they put that problem there. I don't know. All right, equals C squared. What do we say we do to get C by itself? Square root it. That's right. Square root this, square root that, and what's C equal to? What's the square root of 25? It's 5. That's right. What if I said, real quick, I know the bell rang, but what if I said this was 2 and this was 3? What's C going to be? Let's do it real quick. Ready? 2 squared plus what? 3 squared. Let's see what that's equal to. 2 squared is 4 plus 3 squared is 9. What's that? 9 plus 4. 13 equals C squared. What do? Square root both sides. What is C? It's the square root of 13. So just because it goes in order doesn't mean, just because I have a 2 and a 3 doesn't mean that that's going to be a 4. Everybody see that? If this is 5 and this is 6, does that mean that's 7? No, it doesn't. This thing right here, we call this a 3, 4, 5 triangle, and that's called a Pythagorean triple, is what we're going to talk about tomorrow. Okay, a little bit more with that. We're going to do some more Pythagorean triples. Good? All right, no homework. All right, take it easy. Enjoy your day. Hope you have a better day than what you've been having so far.